At last! My very own time machine!
How about I try it out?
No! That's my time machine!
Huh?
Ha! It works!
What's up, everyone, and thanks for tuning back into UFO Chaser. I'm Jason, and today we will be looking into time travel, an idea that mankind has pondered about for many past years. It has been portrayed in movies, mentioned in music, books have been written about it. Some even believe ancient civilizations had the capability to travel through time. But let's take a look from a scientific point of view through research and studies on what we know today. Thanks for watching, and as always, much love.
Let's start with Isaac Newton. Isaac Newton believed that time was like an arrow. Once you fired it, it went in a straight direction. 1 second on the Earth was 1 second on Mars, was 1 second on Jupiter. It never reversed directions. Along comes Einstein, who says, not so fast, not so fast. Time is like a river, old man river, that meanders around stars, speeds up and slows down. The new wrinkle in all this, which is causing all the excitement and the dismay of philosophers, is that this river of time can fork into two rivers. Or perhaps the river of time can have whirlpools and time can go in on itself. In that case, time travel is something you have to take very seriously, because Einstein's equations do allow for time travel. And they're blueprints, blueprints for different kinds of time travel designs that are compatible with Einstein's theory. For example, gigantic spinning cylinders. You go around the cylinder and you come back before you left. Colliding cosmic strings. You wind around these cosmic strings and you come back before you left.
And the key element is that in Einstein's theory, it allows this under certain solutions?
That's right. Time and space are like a fabric, like rubber, like a trampoline net. However, if you stretch the trampoline net so much, it can rip, perhaps. And perhaps you can turn this trampoline net into a pretzel and allow yourself to go backwards in time. Now, of course, there's a catch. There's always a catch in these things. The energy, the gasoline necessary to do this is fabulous. Even an atomic bomb does not have enough energy to drive a time machine. For a time machine, you need the energy of an exploding star.
How about all the logical paradoxes that one would come across in time travel, going back to the past, killing your grandmother, and all of those kinds of issues?
Or meeting your teenage mother when she's a teenager and she falls in love with you. So how can you be born if your teenage mother just fell in love with you? There are two ways to resolve these paradoxes. The first is self-consistency, that if you want to shoot your parents before you're born, there's something preventing you from pulling that trigger. Maybe there's a hidden law of physics that says you cannot create a time paradox. I don't believe that.
Yeah, that seems far out.
That's far out. I believe that the river of time forks into two rivers. If you saw Back to the Future Part 2 very carefully, Doc Brown, this Einstein figure, goes to the blackboard and draws a timeline from the 50s to the 80s. And then he draws a separate line that splits off from the main timeline. The river of time forks into two rivers.
Is this getting to the so-called many-world interpretation of quantum mechanics? Would that be?
That is the simplest way to resolve all these paradoxes.
That never seemed very simple to me.
Well, it's the simplest in the sense that you don't have to add any other assumptions other than quantum mechanics.
Sure.
So if you go backwards in time and save Abraham Lincoln from being assassinated in the Ford's Theater, you've saved somebody else's Abraham Lincoln, who's genetically equivalent to your Abraham Lincoln, but you've entered another universe. If you shoot your parents before you're born, you've shot somebody else's parents before you're born, who's genetically equivalent to your parents. So you can go backwards in time continually, monkey with your own past. However, you're monkeying with, in some sense, a parallel past.
Right.
Now, Stephen
Maybe
Hawking...
creating a parallel past,
creating a whole new
universe.
That's right. And Stephen Hawking even said there's got to be a laws of physics preventing this thing from happening. Well, we've tried and tried and tried and failed. We cannot find any law of physics preventing you from going backwards in time. It seems to be consistent with the known laws of physics. The trick is you have to have this energy on the scale of a star. You'd have to be a very advanced civilization. So these tourists from the future are just not 100 years into the future. These tourists from the future would be perhaps millions of years in the future, the ability to control the output of a star. We physicists are hot rodders of physics. We push the equations until they break down. So Stephen Hawking assumed that they would break down. Well, we were shocked. They didn't break down. The laws of physics seem to be compatible with time machines. This is very unsettling because it means that perhaps, just perhaps, time travel is possible for advanced civilizations. Cannot be ruled out.
Imagine if we could send information back to ourselves, to warn ourselves of natural disasters, tsunamis, earthquakes, warn loved ones to stay out of situations that might lead to their death. My name is Ronald Mallett, and I believe that I can make time travel a reality. Gravity can affect time, but in addition to that, according to Einstein's theory, light can also create gravity. And my breakthrough was based on this. If gravity can affect time and light can create gravity, then light can affect time. And this is the basic equation that shows the twisting of space. Now, throughout our entire life, even though we're not conscious of it, we all move along a timeline from the past to the present to the future. Time and space are connected to each other. If I can twist space strongly enough, then I should be able to twist time, which is connected to space, into a loop. So imagine that I take that straight line and I make that line into a loop. Now I can move from the past to the present to the future. So theoretically, it would be possible to actually travel back into the past by using the gravitational field created by a circulating beam of light. But that has to be now shown experimentally, which means that we have to have equipment to do that. So the limitation of a real time machine would be that one could only travel back to the point where the machine was turned on. So that means, in some sense, that we cannot visit our ancestors, but our descendants could visit us once the real time machine is turned on.
Turning this machine on for the first time is something very big.
Well, thank you. It's a pleasure to talk with you about it. And this is the basic principle behind it, is based on using light to actually manipulate space and time. And the breakthrough that I made was actually to show that by using Einstein's theory of relativity, especially his theory of gravity, which says that gravity can actually change time. And one other aspect of Einstein's theory, which my work is based on, my breakthrough is based on, is the fact that not only can matter create gravity, everyone's used to the fact that the Earth is pulling you down and the sun, Earth is in orbit around the sun due to the sun pulling on it. But the thing is it turns out in Einstein's theory, light also can create gravity. And so, according to Einstein, gravity can affect time. But if light can create gravity, then that means that light can affect time. And using lasers, what I've been able to show in my theoretical calculations is the fact that you can, in fact, alter space and time. Now, the thing is that in Einstein's theory, space and time are connected to each other. Whatever you do to space also happens to time. Essentially, what you'll see is each one of these pillars contains a series of lasers. And when it's turned on, these different pillars of light will create a tunnel of light in this region. And that tunnel of light is what's going to cause, is a circulating light beam. And that's what's going to cause this twisting of space. And with more powerful energy, it will actually cause the twisting of time as well. The twisting of space, I should say, is actually what leads to the twisting of time. So it's really necessary first to be able to show that you get this twisting of space. Those are actually two separate experiments. If we don't see the twisting of space, then we can go home. But if we do, then that means that that's a big portion of the success of it. Then the next stage would be to increase the intensity so that we could actually cause a twisting of time. So that's what you'll actually see, is a tunnel of light that's being created, and that's, as I said, is the thing that's causing the stirring of space. And that's where eventually information will be sent along that tunnel of light to from the future to the past.
Speed of light is constant, and this is true on what we call flat space. space without any local distortions on it. But warps in space-time can make light slow down, bend, or maybe go faster. It should be noted that this is a real phenomenon. Real-life GPS satellites must account for changes in the coordinate speed of light because the Earth warps space-time around it and makes light slower near the surface of the Earth than it is up in orbit. You have probably heard that nothing can travel faster than light, that the speed of light functions as a speed limit. But as we have just seen, warps in space can cause this speed limit to change. And what this means is that space-time corridors that increase the coordinate velocity of light could be used as a fast lane for travel between stars. The awkward thing is, they could also be used to create a time machine. Our argument is basically the same as the argument that can be used to show that wormholes can create a time machine. So suppose we have a very long, dense wire with a particular mathematical form. This is the corridor that I was talking about earlier. We've formulated this wire so that the speed of light, the coordinate speed of light, is faster in a limited space around the wire. That's the warp space shown in red. For simplicity's sake, we'll use the numbers in our example and say that a rocket traveling close to the core of the wire can travel 3 times faster than the coordinate speed of light outside the wire. This animation shows 2 rockets. The one outside the wire is traveling at 99% of the normal flat space speed of light, and the one inside the wire is traveling at 3 times the normal flat space speed of light, or 3c. Note that I'm not showing any relativistic effects such as length contraction on the rockets. This is basically an animated diagram that shows the position of the rockets over time. Here we have 2 of these wires, close together but not touching. Remember that they are very long and warp space-time nearby. I will put stripes on these wires to make it easier to see if one of them is moving. First, we're going to send a rocket to travel a loop around these wires without moving either wire, and this is just to show you what the path is. Nothing strange is going to happen yet. But what happens if we start sliding the top wire at a significant fraction of normal flat space light speed? In the next animation, we will slide the top wire at 30% light speed. It looks slow, but that's just because the rocket is so very fast. Now watch the rocket on its return journey. It looked much faster, didn't it? But the rocket didn't do anything different. This is a consequence of general and special relativity interacting. Again, this is an animated diagram. It doesn't show any other relativistic effects on the rocket. Now, if the top wire slides at exactly the right speed, the rocket's return journey is instantaneous from our point of view, which is another way of saying that the rocket's coordinate velocity on its return journey is infinite. So what happens if we speed up the top wire even faster? Watch carefully, this is weird. Yes, there are 3 rockets on screen. Where did they come from, and where did they just go? In fact, there's only 1 rocket, but it's looping around in time. You may be familiar with this concept from assorted pop culture things. And this is the wire time machine model. Other faster-than-light travel schemes, like wormholes, tend to make time machines the same way. And if faster-than-light travel can cause time machines, then it can cause paradoxes.